For exam 2, no. You cannot use your notes for exam 2. No notes. For exam 1 and 5, it's a open book. You can use your notes, but you cannot use computer. You cannot use another application. It's a lockdown browser. It's not a lockdown monitor. You cannot browse for the answers, but you could use your notes for exam 1 and 5. Okay, did you watch the PowerPoint presentation for Kinetics? I had two. I had limited access to internet, so I couldn't. Okay, perfect. Do you have any questions? Okay. The some of the sample questions here that you've seen in your assignment for kinetic from Newton, also when you are giving concentration or you are given change in concentration and change in time, is just asking what is the average rate. So basically it's the rate is change in concentration. Rate equals change in concentration over change in time. So you can do the calculation. I didn't expect you to have any problems or, difficulty to figure out the rate using the definition for the rate, but I just wanted to make sure that this is given here as a sample question. The change in rate or change in concentration is going the final minus initial, so 0.43 minus 0.23 over change in time, because it says over 8 minutes, so this you can change to the 8 minutes, and then just do a simple math, 0.2 over 8, and that is going to give you 0.25 mole per liter, or molarity over time. Unit of time here is minutes. If it's a multiple choice and the answer is given in mole per minute or molarity, change in concentration per minute, you can stop here. If the answer choices are given in seconds, then you have to change it to seconds. But if the choices are given in minutes, you stop here. That's the only challenging part, in case if the choices are in seconds. Other than that, there is one concern here about the half-life. The half-life, or T1/2, is written based on the integrated rate law. There is one slide on second PowerPoint that I presented. If you look at that video, there's one slide that gives the summary of zero order, first order, second order rate law, integrated rate law, which shows the concentrations and the time, and then half-life for each one. And there is only one magic for that. You have to memorize it or be able to come up with the equation yourself. So to come up with the equation yourself, you are going to put A, concentration at a given time, equal to A0 divided by 2, and then rearrange your formula to get the T1/2. The process is explained in multiple slides in the second part. Unit 3. No, Unit 3 is not going to be on the exam, but is going exam 1, but is going to be an exam 2. So you need to know the Unit 3. So we are now working on Unit 3, actually, is kinetic. So since it was a question, I just had to answer that question, that for the half-life, how do we come up with? So what does it mean if it's the half-life for first order, for second order, for zero order? what is the formula for half-life. I do have a couple examples in this presentation. It's just like 10 slides. I'm going to go over and I show, and hopefully that answers your question, Ruth. So another example says the concentration, the time is given and concentration is given, is asking for rate, or what's the average disappearance rate. So between the 160 to 200, so basically the 200, you find the time here, so it's going to be 200 minus 160, and then this is going to be changing concentration, is going to be 0.288 minus 0.36. It's going to be negative value because it's written based on the reactant. The concentration for reactant is going to decrease, and that's why when you're writing the rate based on changing concentration of reactant, you would apply a negative value here, changing concentration of A over change in time. So in this case, if you have the changing concentration, the time is 40, and then changing concentration, whatever it is a negative value, and times this negative is going to be positive. Okay, so basically 288 minus 0.36. So you find this value is going to be, whatever this is going to be negative value, and then that negative times this negative is going to cancel each other's effect. So the rate is not going to be expressed negatively at the end, because it's showing what's the change in concentration. Is not saying if the concentration is going to be lower or higher. So you apply this negative formula, negative as part of the formula. Okay, we have a reaction here, and it says if the rate is 1.4 molarity per hour, basically is a capital M per hour, that's for O2. What would be the concentration, or what would be the change in concentration or the rate based on H2O? The coefficient is going to affect the rate expression. So if for O2 is 1.45, what would be for H2O? What's the ratio of H2O to O2? The ratio for H2O O2 is a 6/5, and you basically multiply this by the 1.45, and that gives you, this is for the O2, and then this is going to be H2O O2. O2 would cancel with O2, then whatever you find as the answer is going to be molarity per hour for H2O. So the rate expressed for one reactant or product is related to another reactant or product based on the mole ratio in the balance equation. So if it's given based on 1, you are trying to find based on another reactant, another compound in the reactant or product side, is you are using the mole ratio from the balanced equation as the conversion in order to convert to the other. So basically it's just like mole ratio. Finding the rate law. So the general rate law depends on how many reactants you have. You have 2 reactants, going to be rate equals K, concentration of A to X value, and concentration of B to Y value. In order to find the specific rate for this reaction, you need to find the value for X. So what is the value for X? What's the value for Y? And what is the value for K? If you find these 3 items, then you have a specific rate law for this equation. The numbers are given here, the concentration for 3 different trials. So you are using 3. If you have 2 reactants, you have to use at least 3 different trials. If you have 3 reactants, you have to use at least 4 different trials. So your number of trials must be one more than the number of, at least one more than the number of reactants that you have in the reaction mixture. So in order to find the value for X, which 2 are you going to use? You have to use the 2, a set of 2, that the value or the concentration for B is constant. So since B is constant for 1 and 3, we are using trial 1 and trial 3 to find X. Okay, so to find X, we are using 1 and 3. Why are we using 1 and 3? Because the concentration for A is changing, but concentration for B is constant. In order to find Y, we have to use 2 that they are, so this is to find X. To find Y, we have to use 1 and 2 because to find Y. One and 2 because A is constant and B is changing. So we are using this to find Y, value for Y. In this here is M and N, it's the same thing. So as long as you understand what's the justification for me using reaction 1 and 3 in order to find the exponent for A. Exponent for A could be X or M, it doesn't matter, but concentration for B should stay constant. So that's why we are using 1 and 3, because concentration stays constant. Then you write the rate, because the rate is going from rate 3 over rate 1. That equals K when you have concentration for 3, for trial 3. So is a 0.06 for A, and then you have here X. For B is 0.05. K, concentration of 0.05 to X, concentration for Y is 0.05 to Y. So you have a ratio of rate 3 to rate 1, and then you have this fraction. You can cancel some of these items. That's the good thing when you're keeping 2 of, it doesn't matter what Y is, but the value of 0.05 to the Y is going to be the same, whatever it is, because this base is the same and the exponent is the same. So it's going to cancel each other. The value for K is going to cancel. So what you have here, rate 3, which is 2.505 over 2.505 equals 0.06 over 0.05 to the power of X. Since this is 1, what should be the value for X? Okay, because this value is 1, the only time that you can get a fraction or any number to the power of something to get 1, the X must be 0. So you can do this calculation and then say to the power of X equals 1, or you just say this fraction, whatever it is, because it has been raised to a power that results in 1, then 1 equals 0.06 over 0.05 to the power of X. As a result, x equals 0. So that's how you find the value for x 0. And in order to find the value for y, exponent for b, you are using 1 and 2. So you are going to say rate 2 over rate 1. In this case, you are going to say rate 2 over rate 1. So rate 2 over rate 1 equals k, concentration for 2, which is 0.05 to x, concentration for b, 0.06 to y, over k. For rate 1, we have concentration of A 0.05 to x, concentration of 0.05 to y. The value for rate 2 and rate 1 is 3.006 over 2.505. So you write the equation for rate 2 and rate 1. You divide rate 2 over rate 1. You divide the values as well. Simplify it. So in order to simplify, which are like terms that can be simplified, is the values for k, whatever it is going to be cancelled at this point. So value for k is going to be cancelled. Value for 0.05 to x, it's going to be simplified with this one. At this point, we do know the value for x, but in case if we made a mistake in determining value for x, we are not using the actual value or found value for x. We're just going to simplify it. Then you find this, you are going to find this value. You would say 0.06 over 0.05 to the power of y equals 3.006 over 2.505. So the value for y, you have to simplify this and then say what is the value for y, that if you raise this ratio by that exponent is going to give me this value. So this ratio by this exponent is going to give me this ratio. Okay, so if you find these two values to be the same, then this must be, y must be 1. So this is like a 0.06 to 0.01 or 0.5. So it's the same. These values are the same. So the only way you could have 5 to the power of x equals 5 is if x is 1. So it's the same argument here. So here we have 1.2 equals 1 to the power of y equals 1.2. So what should be the value for y? Value for y would be 1. So you find the value for y. I don't know how many of you have difficulty. I don't want to repeat exact same questions because we do have a couple of these. And if you have any questions, you let me know. How do you find? You also need to find the value for k. To find the value for k, as I said in my previous PowerPoint, recorded PowerPoint, you take one of these set, one experiment only, and then you would plug in the numbers. So the rate at this point is, so far we found that rate equals k, concentration of A to 0, concentration of B to 1. And we simplify this to K concentration of B to 1. So we already know this as the new rate law for this experiment. So if we know that rate equals K concentration of B to power of 1, then we can substitute the values and find the value for K from one experiment. So we need the value for B and we need the rate. So rate, just change the color. So rate is 2 point for trial 1. We are using trial 1. 2.505, which is the rate, equals the K times 0.05 to the power of 1. You divide both sides by 0.05, 0.05, and that gives you the value for K, and K equals 50. Use your calculators. You are always allowed to use your calculator. So it's going to be 50. What's the unit for K? Unit for K is going to be per second. And how do we know it's a per second? Because this is the first order reaction. Is first order reaction, or another way, this is molarity, and this is a molarity over second. What should be K, that if you multiply by molarity becomes mole per second, so K must be 1 over second, or reciprocal second. So that's how you find the unit for K. And then when you have the unit for K, you have the value for X and Y, you have the value for K, you have your specific rate law for this reaction. This is very similar. I will only go over if you have questions about it. It's very similar. And then you have the initial rate concentration is the first order reaction. What does it mean is a first order reaction? It means that you have your rate law, or ln A0 over concentration of A at the given time equals KT. Because if you are dealing with the concentration, or you want the relationship between the concentration and the time, that's this form of the rate law you need to use for first order reaction. So the rate, okay, initial concentration, label your data. So this is A0. Time, we have the T, concentration. The concentration is going to be after the 30 seconds is going to be this value. So we have the A at T. If you know your formula, there's just one slide and you have to memorize them all. So if you know the concentration time relation for first order reaction, you know the general rate law for first order reaction. If you have the half-life equation for first order reaction, you can answer any questions if if you read the question carefully and you know which equations you must use. Okay? So if we have this number, this equation, and we label our data, all is asking to find the value for K, so it would be ln. Then we have the concentration at 8.0, which is 0.372 over concentration at AT, which is 0.0744, equals K times 30. Okay. So if you divide both sides, you have to first find this value, get this ratio, and then find the value for, take the natural log of this value, the ratio. If you have the natural log for that number, then you can divide by 30 to get the value for k. So you find the value for k equals 5.36 times 10 to negative 2, and is going to be per second. Why is per second? Because it says first order reaction. So the unit for k is going to be this for first order. Just emphasizing, so in case another formula or another question is giving you the value for k, then from the unit you can extract the information that this is a first order reaction. Okay, so if you read the question, you label the given information, and then you recognize for first order what is the equation, you just plug in. If you have any questions, use the chat area to give me your question so I can help you. The rate constant for the first order is given. So we have the value for k. We already know is a first order reaction. So if it's a first order reaction, then we have ln a 0 over ln over a t equals kt, or concentration at AT equals concentration at 0 time e to the power of kt. So basically you take the anti-log of the anti-log from both sides. So when you have this equation, now k is given to you, concentration t 8 second, what is the initial concentration? So this is what we are trying to find out. The AT is given to us, T is given to us, so this value is AT. And we have the T, we have the AT, we have the value for K. The only one that is missing is A0. Learning how to use your calculator is the key for solving problems that is going to use log, natural log is going to use the E expression. So you need to know from one calculator to another calculator is different, but you have to use, especially when you have a solved problem like this, and we know that I already checked and the answer is correct, so there's no error. So you can practice with this using your calculator, making sure that you can take the natural log of a ratio, you can take the anti-log, you can take the, go from integrated to the normal rate law to practice, so you be prepared for your exam time how to use a calculator. First order reaction again. So if you have first order reaction, the only reason I brought this because it says 60%. What does 60% means? Meaning that AT to A0 is 0.6. That's the only point of this problem that is different from the others. So you do natural log of 0.6 equals KT, negative KT. That's all it's new in this problem. Everything else is the same because the value for T is given to you. Sorry, this is the value for K is given to you from the unit. You have the value for K. And you have the ratio. So the value for K is given. This ratio is given, which is a 0.6 because it says 60% of the initial amount. And then you find the T. You're trying to find the T. Half-life. Someone had questions about the half-life. For the half-life, what is that you need to find out? First of all, what's the order of the reaction? If it's a zero order, you need to know the formula for zero order. The half-life formula is concentration at the zero time divided by 2K. Okay. So from this zero order, you come up with this formula. Then you're going to plug in your number, the rate constant, the value for K is zero order, so the value for unit for K is going to be mole per liter per second. Okay. The value for A0 is given to us, so we have the A0 given to us, and we want to know what is the half-life. So if this value is given, K is given, you know the formula. That's all you do. You do the calculation and to find the T1/2. And I think, who had problem with the half-life? Was it Ruth or somewhere else? Did I answer one of your questions about the half-life? Okay, perfect. So that's how you approach the problem with the half-life. You need to know the only thing that you may, that you are responsible for is the formula for half-life based on the order of the reaction. So if you know the formula for half-life for the order of the reaction that is given, even if it didn't say zero order, if it's more challenging problem, it may not give you the zero order, but it gives you the unit for K. So if you know unit for K is mole per liter per second, this corresponds to zero order, you still should be able to come up with this equation. But most of the problems that I saw in the Newton, they are more gentle and they're giving you the order. Plus the PowerPoint that I had, it didn't give you the order. It just gave you the unit for K and expected you based on to find out what is the order based on the unit for K, which is a good thing to know. Rate constant is per mole per hour. So if it's per mole per hour, unit for the rate constant, this is the K, and that's the unit. So you need to know this is the second order. Oh, it tells you it's a second order. But based on the unit for K, you should find out this is a second order. And then this is talking about half-life. Half-life for second order. What is the half-life for second order? So half-life for second order is going to be 1 over K A0. So, sorry. So if you know it's the second order, and that's the formula for half-life for second order, then you read the questions to see what is given to you and what is asking for. Okay. So if it says initial concentration, so we write this one as A0. The unit, it shows that this is it says rate constant, so we have the value for K, we have the value for A0, and we're trying to find the half-life. If the half-life was given to you, you could find either one of them, whatever. So 3 variables. 2 should be given to you and 1 is the question normal. Okay, these are the problems that I found that I thought maybe as a sample problem you would benefit from. But do you have any questions that I should go look for? Any specific question? If you don't have specific questions, I'm actually going to stop the recording because I was recording, so it's going to be available for students who were not here now for this session. Also, I want to make sure that you can take the rest of the class time to take your exam because it ends in Sunday. But it has been open already. Make sure to review for the exam. Go to the review. It's called a review. Let me see what it's actually called. I think it's called the review session. Test Review Center. So it's called Test Review Center. Yes, it does end Sunday. What you need to know that questions are going to be similar but not same questions. And the review center, it will provide the review for the exam based on your performance for assignments for Unit 1 and Unit 2. And then it gives you the answer to those questions. Also, when you check your activity. If you go to assignment and check for your activity, it's going to show you the answers regardless if you have the right or wrong answer to the question. So that's another good place to review for your exams. Exam 1 is not honor lock proctored. Exam 2, 3, and 4 are honor lock proctored. And then your exam 5 is not